Lesson 1.9. Title for this one is Speedy Delivery. You can find it here under Unit 1A, Constructions. Here we go. So, for speedy delivery, here's the idea. Well, let's start off. What do you notice? What do you wonder? There's lots here, right? We've got a square. Looks like a square. Close to a square. We got a lot of points. We got a few rectangles. This big square thing is divided into rectangles. It looks like there's 3 in each one. Let's see. A, B, C, D, E, F, G. What happened to H and I? And then there's J. I don't know. What do I wonder? Why is there 3 in each one? How come some rectangles are bigger than the other? Is this actually a square? What does this represent? Lots of questions to ask, right? Okay, here is a square city with 3 locations of the same store. We're going to pretend that we're dealing with a pizza shop, right? Let's say that we own a pizza chain and we have these 3 stores. Well, the things we need to think about here are, how do we keep our customers happy? We want them to get good pizza, and we want that pizza to be hot when they get it. So if somebody orders and we find out that their address is like right here, we don't want to try to deliver that pizza from this store over here. That wouldn't make any sense, right? So we're trying to figure out a way that we can divide the city up so that we can make sure that no matter where they are in the city, wherever they want that delivery to be, that we always cook that pizza and deliver it from the store that is closest to them. Now, we have some tools in our toolbox that are useful in those respects, right? So let's see here. We can make a perpendicular bisector, right? Because halfway between, if we just look at E and F for right now, let's just look at E and F for right now. If you look at those, we could make a perpendicular bisector between them, and that would mean that anything on this side would be cooked at E and delivered from E, and everything on that side of the line would be delivered from F. So let's make a perpendicular bisector. Here we go. So we use the compass tool. We've done this a bunch of times, right? Here's this. There's one circle. Here's this. There's another circle. Oops, there we go. Got to center it on that. I'm going to zoom out a little bit so we can see everything. And maybe adjust this a little bit so that we can. There we go. All right, cool. So we can now see these 2 intersecting points, and we know that those are the points that we use to create our perpendicular bisector. Right? There we go. Ta-da! Right? So everything on this side of this line comes from E, and everything on that side of the line comes from F. That's if we only had 2 pizza shops. But we don't. We own 3. So let's say that somebody ordered from like right here. We would want them to go from G, right? So it's possible that it could be closer to E, but it might be closer to G than to F. Or to E, sorry. Closer to G than E, but still further away from F, right? So we're going to do the same thing over here. We're going to make another perpendicular bisector between E and G, right? It would split a segment in half between E and G, and we can see that there's the point. There's one point. There's another point. I'll use the intersect tool to find these 2 points. And there we go. We're going to use a line tool, and there is our other line. So everything above this line would go from E, and everything below would go from G. Well, so far we've got everything like E is all the stuff up here, right? And G and F, well, you could still be closer to G than to F, but still be on the right-hand side of this line, right? Right in here somewhere. So we need to create another perpendicular bisector for G and F. Here we go. Compass tool. And again, compass tool. All right. Now this is where things start to get a little bit confusing. because there's so many circles, it's just crazy looking at it, right? So one of the ways that we can do this is we're like, okay, where is this line? Where does this line go? Well, we have to think about this. The circle around F that goes through G is the inside circle around F, right? But the circle that's around G that hits F is the outside circle around G. You might have to play that back in order to hear it again, right? So we're going for the outside circle here and the inside circle here. And so that'll give us our intersecting points. So inside circle, outside circle there, and the inside circle here, but the outside circle there. That would be right there, I believe. And then set up our line, our perpendicular bisector. Boom and boom. Okay, cool. Well, what do we notice here? Well, geez, look at that. All these lines meet exactly at the same point. Well, let's think about that. What does that mean? What does that point represent? What's the story with all these lines anyway? Well, we know that if they're perpendicular bisectors, they're exactly halfway between the 2 points, right? Everything on this line is halfway between E and F, right? This is an equal distance from E as it is from F, right? Everything on this line is. But if we go to this perfect point right in the middle, guess what? That is the same distance from every single pizza shop. So if somebody calls us from this corner, we could make that pizza in any shop. So what we're going to do now is we're going to map out for this city where the zones are, okay? We're going to use the polygon tool. Here we go. We're going to just follow these lines. We're going to look at this. And we're going to go, okay, for E and F, this is the splitting line. So this is going to come down from here. It's going to go to this center point, right? And then, well, it wouldn't go this way because that would be in the G territory. So over to here, and then up to here, and then back to our other corner. Now that's really hard to see, so I'm going to adjust the color on that. So I'm going to select that object right there, and then I'm going to adjust the color. Make it pop a little bit better. There you go. You can see that that's the green section. So the E store is getting this, everything in this section of town. Okay. All right. Now what about the F section of town? All right. Well, let's look at F. F is going to be on this side of this line up here. But if you go past point O, you're going to be closer to G. So this must be the other line. So it's going to be looking like this. So here we go. Let's grab our polygon tool. Let's set up our colors. Whoops. Wait a minute. Set up our polygon tool. Adjust our colors. We're going to go blue this time, and we're going to make it just a little bit darker. There we go. Whoops, didn't mean to do that. Okay, here we go. Start from this corner here, go over to N, go down to O, down to here, this corner here, M, and then up to there. And that is the area around the shop for point F, right? Point F is going to deliver in this section of our mysterious square city. And of course, this white section is where we're going to get all of the pizzas from G. So I'll put this one in red, and here we go. From P to O, down here, down there, and back. Right? So there you go. That shows you how we're going to set this up. All right. So that was a refresher on how useful perpendicular bisectors can be for mapping, for finding halfway between things, and how you can start to make that a little more what happens when you have more than just 2 points that you're working with. So this was 3 shops. Shop E, Shop F, and Shop G. Well, guess what? All right, so the company wants to break the city into regions so that whenever someone orders from an address, their order is sent to the store closest to their home. They've hired you to decide how to partition the city, and you just did that, right? You did that. You split the city up, and you did your job, all right? Okay, explain or show your reasoning. There you go. So if there's 100 employees, how should they be distributed among the 3 locations? Now, right, that's what this question is. How would you split up all your workers? Should it be the same amount for each one? I don't know. Well, if this city is exactly, everybody lives, there's no like closer neighborhoods, tighter knit neighborhoods with there's no like apartment buildings. If it's all just like row houses after row houses, there's no subway stations, there's no other buildings, it's just houses, 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 houses on a grid, right? All the way through, then it would be just pretty obvious that G probably has the most space, right? So that would mean the most people live in that area, right? So they are probably going to order the most pizza, right? So you would split this up based on which store has the most area around it, right? If everybody orders pizza at the same rate. Is there anywhere in the city that has the same distance to all 3 stores? Well, we answered that question. It's the spot where all the perpendicular bisectors cross. Okay, so now we open a 4th store. We got to partition the city again. We got to split it up. All right, here's what I'm going to tell you. We actually have a tool for creating perpendicular bisectors, because making all those circles with four shops would be super confusing. So what we're going to do is I'm going to show you that we have a perpendicular bisector tool. You'll notice that it looks like a line that splits a line segment in half. So here we go. All we have to do is go, okay, from E to F, there's our perpendicular bisector. From E to G, there's our perpendicular bisector. And from G to Z, there's our perpendicular bisector. And from F to Z, there's our perpendicular bisector. And let's see, did we miss any? Oh yeah, from G to F. We missed that one, right? All right, so here's that spot, right? When there were only those 3 stores, E, F, and G, there's that spot. But look, here's now another one with these. It's the same distance away from these 3 stores. So now we have to split it up again using the polygon tool. So here we go. Let's change our settings on the polygon tool. Whoops. There we go. Start off with green. Let's make it a little more green so that we can see it when we're doing it. All right. Great. So we know that this line comes down here, goes to this magic spot here in between E, F, and G, and we know, so there's no way that anything in this area is going to be closer to Z than it is to G. So we don't really have to think about point Z right now. So we're going back up. We got this. All right. Shop E is done. All right. So now let's look at shop F. Okay. Well, we know that this area up here is all definitely closer to shop F. Well, since we added this new store down here, where's the extra line? Well, the extra line is right here. It splits F and Z. It's this line right here. So when we look, oh, I got to change the color here. Let's go to blue. We're going to go like this. We're going to go down here and, this is the line between F and G. And it goes to this point here. And then this is the line between F and Z. So we end up with that for our shop F. And when we go on to our next, so notice I click on the move tool and then click nowhere, and that allows me to change, and then I click back on the polygon tool. That allows me to change the color without changing the color of whatever I was working on before. All right, so here is shop. Let's do G, I guess. So we'll go from J. We know we're going out to this spot here. We're going to go down this way because this line splits. It splits G and F. And now this line here along this edge is the line that splits G and Z. So anything, you can't cross that because as soon as you cross that, you'll be closer to Z. So now you go down here like this, over to the corner, and then back up to J. So this is the area for shop G. All right. So click on the move tool, reset the tool, get the polygon tool, change the color. I guess we'll go with brown, right? And now we're going to do Z. Well, it's this, whatever's left over here, right? This one, that one, that one, and that one. There you go. All right? So there you go. That's how you do this. That's how you do this. Okay, task 7. Oh, so let's think about this. Now, which shop do you think should have the most workers in it? And which should have the least workers in it? Well, I would look at this and I would go, well, Z looks like the smallest area. So that would be the shop that I would have the smallest number of people working in, because they're probably not going to get the most number of pizzas. Shop E is probably going to get the most pizzas now because it's the biggest one. It looks like the biggest area to me. G's still pretty big, but I think E might be a little bit bigger. Anyway, it's definitely not Z. Okay, so here we go. In 1854, there was an outbreak of cholera in London. A physician, a doctor named John Snow, thought the water supply might be responsible. He made a map showing the location of all the water pumps in the city and all of the locations of all of the deaths due to cholera in the city. How could he have used the ideas in this activity to help isolate the cause of the outbreak? The diagrams you made in the activity and that Snow made are called Voronoi diagrams, and are still actively studied by mathematicians. So let's think about this. Let's say that these are the 4 water supplies in the city, and we notice that. Or here, why don't I? Let's do another. Let's do a different one. Right. So let's say that here are the wells, the water supply places in the city. Okay, remember this is a long time ago when people had to pump their own water. Look, it's like 1854. Didn't just automatically come out of the tap. You had to go down, find the water pump the water, collect it, bring it back to your house. Okay, so here, let's say there's these 3 water pumps in the city, and we notice, or heck, let's put a bunch more, right? There we go. Okay, and we notice that, oops, go back one step. Okay, so that's the water supplies. Okay, now I'm going to mark all the places that people died. Okay, all right. Okay, so if this is all the areas where people died, what would you start to think? Well, I would go, hey, it looks like the people that live right around this well, and this well, and this well are all dying. But the people that tend to get their water from these are not dying. Maybe that's because the water is not contaminated. So if I check this out with a perpendicular bisector tool, right? And I go like this. We can already see that, right? If you're closer to E than F, you're probably getting your water from here, and there's people dying, right? If you're closer to B than G, you're probably getting your water from B, and there's people dying over here. So this was before. Right? This takes place in 1854. This is before people realized that how important it was to have a clean water supply. So cholera is something that gets transmitted or acquired. I mean, you catch the disease through contaminated water. Okay, so this task right here, task 8, you don't have to do this because this is actually the mastery check for 1.9. I have a map of Philadelphia, which if you click in here, you will see that there is a map of Philadelphia that I made. And here are the pizza shops. L, M, P, Q, O, and N. L, M, N, O, P, Q, yeah, L, M, N, O, P, and Q. Yeah, and you basically just have to create a diagram and split the city up for the delivery zones. Okay, that's your job. Okay, and of course you can zoom in if you want to get a little bit closer to it, but that's the idea. Okay, but remember, you're not doing that until you have finished the lesson part and the practice for lesson 1.9. One other thing, remember that there are resources on the class website, and the class website definitely includes some information down here. All right, that's about it.